Welcome to Data Bytes, Managing Data in Spreadsheets. My name is Kay Bjornen. I am the Research Data Initiatives Librarian at Oklahoma State. And our workshop today, we have these basic learning objectives. We're going to talk about good data entry practices and how to use a spreadsheet effectively. We're going to look at common formatting mistakes and how to avoid them. Discuss approaches for handling dates in spreadsheets, and look at a couple of tools in Excel for basic quality control and some data manipulation, and then talk about how to export the data from spreadsheets. This lesson is adapted from a data carpentry lesson on using spreadsheets, and the URL for the complete lesson is down there at the bottom. The actual carpentry's lesson is a bit longer than the hour we have allocated for our workshop today, so some of it has been a bit condensed. So let's start by talking about virtually everybody uses spreadsheets, loves spreadsheets. And most of us are very familiar with Excel. There are other spreadsheet programs out there. One that you may want to explore is Google Sheets, because it's available in the cloud and you can use it for collaboration. But we're going to talk about how we all use our spreadsheets. And one of the things that we'll look at is the fact that the way we currently use them is not necessarily the most effective if what we want to do is have our data available for use in other programs. So I'm going to start by looking at an example of a spreadsheet that I actually borrowed from a colleague. And if we look at this spreadsheet, what we see is that it is collecting water analysis data, and that the tabs along the bottom indicate that the data is collected for a number of different locations. All of them are creeks in Oklahoma. And the data is in columns. So we have the sigma, the standard deviation. We have a predicted quantity for total dissolved solids and percent error. These are columns that have been generated because the data set is being used for some statistical analysis. And then we have a small table that's inset here, where you see we have the number of samples that are analyzed and the standard deviation for those samples. And then we have another little summary here where it indicates the name of the site, the geospatial coordinates, and some averages of the statistical values. And if we look at the other tabs, they all look somewhat similar. This one's expanded to show some additional fields. Okay, so I want you to remember that spreadsheet as we talk about how we're going to do a better job with setting up spreadsheets. And with that, I'm going to go back to the slides. So one thing that I would like you to think about is that when you use a spreadsheet, there are a number of things you may be using it for. One consideration is that when you set up a spreadsheet, you should remember that you are not the only one likely to be using it and trying to interpret it. Researchers often tend to use spreadsheets like lab notebooks and collect all kinds of data in it. And very often it's data that is familiar to the person who assembled it, but not necessarily clear to others. So layout matters. And so let's look at some examples. So these are all tables that are created with the same data. And this was all, these are examples that are taken from R for Data Science. The authors Hadley Wickham and Garrett Grolemund are at the bottom, and there's a link that goes to the PDF of that book if you're interested. And so let's look at Table 1. Table 1 shows that we have columns for country, for year, for cases, and for population. And so at the top, it's labeled as a tibble, 6x4 tibble, which if you are an R user, you will recognize. And each column with the country, you can see that the country of Afghanistan is repeated, Brazil, and China. And that's because there are data points for 2 different years. And so for the cases for those years and the population for those years are both recorded. Table 2, it's organized differently. In Table 2, the country is still in a single column, but now we have it organized in such a way that the second column also has years, but the third column, we have both the number of cases and the count shown in that column, or labeled in that column, and then the count shown in the fourth column. Table 3, we have, again, the same country column and years, but now we only have 3 columns, and the last column actually shows the count for number of cases over the population. Very likely, well, it's shown as a rate, so this is a ratio. It's likely that they would use this for additional calculations. And then the final example on Table 4 actually splits it up into 2 separate tables and displays for each country, shows the 2 years, and then the cases and the population separately. So your cases are in the first column and your population is in the second column. If you have used spreadsheets to any degree, you have undoubtedly discussed with yourself how the best way to set up a spreadsheet is. And part of the answer to that depends on how you will use that spreadsheet. Because if you are organizing it for a publication or for a further analysis or something, you may be organizing it for that purpose. But we are going to focus on making a spreadsheet so that it is machine readable. And by machine readable, we mean that a software package will understand what each of those data points means. And so common software such as R, Python, MATLAB, OpenRefine can be used to clean and organize your data, analyze it, visualize it. And in order to do that, it has to be able to find the data points and know what it's looking at. So let's plan in advance so that your spreadsheet data can be read by these and by other software programs. So the question is how? And the answer is what we call tidy data. So again, if you are an R user, you undoubtedly recognize this term. Tidy data refers to data from the tidyverse package. And it is data that's in columns. So all variables are in columns. Observations are in rows. One data point in each cell, and it must be saved as a CSV or other non-proprietary file type. And the reason for this is because tidyverse uses data in vectors. So the columns are all the same values because that vector is how tidyverse will look at that data. Okay, let's look at an example of data that is not tidy. So this table was data that was collected by a student. And you can see the first column is the date it was collected. Second column is, the plot it was collected from. And then the third column is species and sex. So it has a code for the species, and then either M or F for male or female, and then the weight. So the first thing that you'll notice about this is that the variables are listed in columns, but, and of course the occurrences are listed in rows because they're listed by date. But what is not following the tidy data rules is that species and sex are listed together. And so let's look at how that would need to be rearranged so that this is now tidy. And the answer is it would require separating the species and the sex. This data is all taken from the data carpentry lesson that I referenced earlier. There are additional examples that you can look at. But now let's talk about cleaning data. So if you have data that is not clean or not tidy, you will need to do some manipulating. The very, very, very first rule is that you never edit your raw data. So before you begin doing anything with your data, you will want to make a copy and preferably store it in an entirely separate location, a separate folder, and label the raw data separately from the manipulated data. In addition, it's a very good practice if you are doing this data cleaning process to create a README text file that you will save with the data that documents each change you will make. So let's look at an example. So for this example, I used Notepad, which is the text editor I had available to me in my my Microsoft software packages. And I just labeled saved the file as a README for spreadsheet. You need to have an appropriate title, and then just did a step-by-step text of some of the steps that I might have been doing with the data set. Some things that are very commonly done in error with spreadsheets is the following. I'd like you to think back to that very nice spreadsheet that we looked at the start of the lesson, because it demonstrates several of these, including the multiple tables. So the columns of statistical data were one set of data, but then there were also the small table that had the sample numbers and standard deviation, the number of samples and standard deviation, as well as the summary table. There were multiple tabs. Something that I have historically been very bad about is using format to convey meaning, especially highlighting cells in different colors to mean something. And that is something that, I would know what that meant. I might even make myself a key so that someone else reading it might know what it would mean. But software will not know what it means. It will not even see those highlights. Another thing that many of us do is formatting spreadsheets to make it look nice, which again, if you are creating your spreadsheet for purposes of publication, that might be important, but it isn't lost completely when you save a spreadsheet as a CSV file. And so that is not something that is of value. Creating comments or other text in your spreadsheet that is not data cannot be read by software packages. And as we've already shown, combining more than one type of information in a cell. And I'll make a comment about this. One thing that to watch out for, if you are recording a derived value, as an example, perhaps density, and ultimately what you really care about is the density value, but you have to first measure the mass and the volume of the sample. You might just record the density, but the best thing to do is to record your measurements, your mass, and your volume, and then do the actual calculation of your density someplace else, either in a software package or in a different spreadsheet. So, yeah, the spreadsheet we looked at, again, demonstrated a number of these. Let's talk about some special issues. One thing that is very common in spreadsheets and does create a significant amount of confusion is null values that are not clear. So if a cell has a -9999, that looks to a software program like a number. It is probably not. As a chemist, I used to see this type of output quite commonly from instruments when the instruments were not calibrated at such a level that it could read the sample. And so then you would see -999. It did not mean that number. It did not mean 0. It just meant it was out of the calibration range. Blank. If there's a blank spot on the spreadsheet, that may mean that there is a missing value, or it may mean that someone forgot to record a value. A 0 may actually be a numerical 0, or sometimes it may mean that somebody did not have a value for that data cell. Null and none are also text that may not be read as text, or if it's in a column that should be a numerical value, it may not be read by the software. NAs, again, not available. Human readable makes perfect sense, but it has the same problem, and an n/a introduces the additional complication of that special character. So what to do? What is your best option if you are creating a spreadsheet and you want to show that you are missing a data value? The best option is probably a blank, but the other two are, including a text value. This will vary depending on which software package you're using. Most importantly, it's critical that in that README file that you explain what you are using to designate a missing value in your data set. Additional common errors are including metadata in the data table. Basically, this just means if you include such things as units to explain to document some important values about your information about your data, that is, again, not going to be readable if it needs to be a machine readable file. We'll look at it in a way that you can include that information as part of the field name. Using special characters of any kind that can't be read by software is another common error. Okay, so now let's talk about how to select or create good field names. And this is basically the labels that you're going to use on your columns. They should be short-ish. And by short-ish, we mean as short as you can make them and still make them meaningful. So abbreviations are good if they're standard abbreviations, but if they're abbreviations that are not going to be meaningful to whoever needs to come along behind and read this or understand your data set, then again, it's better to expand it a little bit. Or again, we can go back to include that in that README file so that it's obvious what that is. Should be meaningful if possible. Avoid special characters and do not use blanks, use underscore instead. So as an example, at the bottom here, we have max temp C, which is clearly the maximum temperature in degrees C. Or it might be max temp without spaces. You leave out the C with that. But what it cannot be is maximum space temp with degrees C in parentheses, because you have space, you have special characters, that is not going to be machine readable. Oops. All right, let's talk now about dates as data. Dates as data create special problems. And we have an example here of a spreadsheet. Again, it's the field data that was used in one of the last examples. And so it shows for plot 3, the date that the sample was collected, gives the species, the sex, the weight, and then this spreadsheet has been modified to add month, day, and year as separate columns. And the reason for that is that, first of all, you'll notice that the date shown in the first column, column A, does not have a year. And it also is formatted in such a way that it may be ambiguous. So, depending on the data point. So, by separating into separate columns, we actually allow the values to be unambiguous. We also allow that each one of those values are now searchable. Another option is to use a date as a string. So this is some examples of that. There's actually an ISO standard for creating dates as a string that is standardized. One of the confusions about dates is that how a date is expressed may vary depending on what country you are in. So this removes that ambiguity. So for example, March 24th, 2015, there's 2 different ways to show it using this ISO standard. The first is the basic, where it's just a single string of numbers. The second one has dashes to make it a little easier to read. But the critical thing is that the string begins with the largest value and then works down. So it's year, it's month, it's day. And if, in fact, you should need to have additional information, such as time, the format would look like the second bullet point, where it's year, month, date. The T indicates that from, after that is time. So then HH is hour, minute, second, and then TDZ is where you're able to indicate a time zone. This kind of expression of time and date might be used for something like collecting pilot plan data or something where that level of detail is important. If you're interested and want to learn more about this, there's a URL there for looking into the ISO standard in more detail. Up to this point, we've talked about spreadsheets and dates in general. Let's talk about Excel specifically. Excel has some very specific factors that can cause particular headaches. And one of them is that Excel actually stores dates as an integer. It indexes dates beginning from January 1st, 1900. So in the table shown here, if you look at the last line, you'll see, first Jan 1900, and in the last column there where it says number, that's how Excel sees that date. This is something that can be useful for some applications, but we're just going to talk a little bit about the ways that Excel can complicate things, because if you export data from an Excel spreadsheet, you can scramble your dates, and your dates will not look like what you started with. For example, the 2 JUL in the first, I guess the second row there on that spreadsheet is entered at, should be Wednesday, July 2nd, 2014. Month and year shows up as July 14. And then we have, if you look all the way to the end, it shows up as 41822. That is the index number from Excel. Now, if we have July-14, that looks at, the 14th day of July, and it confuses it's possible to confuse the date, and the index number is different. It shows up as 41834. Different versions of Excel, transferring Excel spreadsheets between different Excel versions can cause problems. And apparently one area that Excel has been known to cause significant headaches is in bioinformatics, naming genes, because unfortunately, apparently, Excel has been known to take gene names and substitute dates. So anytime you export an Excel spreadsheet with dates, be sure to very carefully proofread it, check the formatting before you do so. All right, now let's look at some useful tools in Excel for data quality assurance. Data quality assurance is what you can do upfront to prevent errors in your data before your data even gets entered. So we're going to use something called data validation, and the process is simply to select a column or group of cells, but usually a column that you want to validate. And then you go to the data tab and you're going to select data validation. So there's a screenshot there of the data validation under the data tab. And then you are able to specify exactly, what data, what format or values you want to allow to be entered into that column. So I'm going to change my screen here, and we're going to look at a spreadsheet and look at what that would look like. Okay, so what I have here, I'm going to show you first the original spreadsheet. This is some further water data that I downloaded from a public website from Arkansas. And one of the things I wanted to show you is that, first of all, if you notice in column B on the original data, it's sample time. So it's the time the sample was collected, and you can see it's, presumably in hours and minutes. And I cut and pasted this data to get rid of the text here at the top. And so that's what this is. And notice what happened to the time. So that's a beautiful example of the way that Excel can scramble something if you don't tell it what that format should be. Okay, so now we're going to do our data validation. And so what I'm going to do is I'm going to just take a look here at this column, which is the analyzed value of ammonia in milligrams per liter. And then up here, I'm going to go to data, and then I'm going to go over here to data validation. And so what I am going to do is I want this to be a decimal value, so I'll leave that. And I could tell it to ignore blank values. So if I knew there were missing data points, that's one way I could prevent having problems with calculations. And then I can go here to data, and I'm going to choose less than. So I'm going to say I believe that all these values under this ammonia analysis should be less than, and let's just make this less than 0.8. Okay. And we say okay. And now let's go over here and let's just select a cell and try to enter 1.5, which is obviously higher than 0.8. And when I hit enter, what happens is that I bring up a message that says, you can't do that because this cell should be, a number that this doesn't match the defined value for the cell. Now, there's actually a way that you can go in and create a message that would say, this value must be less than 0.8, okay? And so you can do that for each one of these columns, go in and individually say, okay, I know what range these values should be. And if you are creating a spreadsheet that you're going to be continually adding values to, and approximately what those values should be and what their limits should be, that prevents inadvertently entering values that are going to mess up your data set. Okay, so let's go ahead and switch back to the slides. Okay, so this is the step-by-step of what we just did. This time, let's talk about using conditional formatting. So conditional formatting allows you to look at data that you've already entered. And so we're going to go through and we're going to use conditional formatting on the same data set and look at ammonia. And the way we do this is we select the column that we want to look at. And then on the home bar, we can select conditional formatting. We're going to use a 2-color scale as a way of examining our data. And we're going to scan the colors to see if anything looks out of place. And we're going to ultimately wind up doing some sorting. So this is a good place to remember that you absolutely want to use a copy of your data, not your original data set. Because if you've used Excel spreadsheets and use sorting, it's very easy to scramble your data. So, okay, so let's go back to that spreadsheet we were looking at just a minute ago. And again, we're going to go here to this column called ammonia. And we're going to go up here and we're going to go to the Home tab and select conditional formatting. And we're going to go down here to color scales and we're going to select the red and the green. Okay. And let's look at that again. Sorry, conditional formatting and color scales, red and green. So what we see is that the red and green looks at a range, it creates the color scale such that green is your low values, red is your high values. But it's not terribly helpful to look at it this way. It will obviously be much more valuable to be able to sort it so that you had all your low values together and all your high values together. So we're going to select all of our rows. And the reason we select all of our rows is because we don't want to sort only one row, because that will scramble our data. All right, so now let's go to home, and we're going to go to sort and filter, and we're going to do a custom sort. And a custom sort, we want to sort by column D, and we're going to sort on values. Smallest to largest is fine, and then let's apply it. Now notice I could have selected the headers and said my data has headers, and that would have compensated for that. Okay, so now let's go through and look at this, and you see that we have zeros are the dark green, and then we have gradually getting darker until our highest value of 0.71 is down here, kind of a dark pink. So obviously, if you have outliers, if you had a something that was 7.1 instead of 0.71, this would make it much, much easier to find that outlier. So this is just one trick for doing that. And again, just be very careful that when you do the sort, that you don't sort without sorting everything, because you want to be able to put it back the way it was. All right, so again, let's go back to our slides. And that brings us to the last step. And basically, once you have got your spreadsheet set up and you are you have cleaned it and organized it in the way you want it, you want to be able to save it in a non-proprietary format so that you can use it with your software. And it's very simple. You're just going to go to Excel. You're going to choose File and Save As, and select CSV as the way that you save the file. You want to save it to the correct location and with a file name that allows you to find it later. And that's it. So one more time, let's go back to our spreadsheet here. And let's just say that we're ready to put this back the way it was. Okay, let's say that we're going to go over here and we're going to save as, and I'm just going to save this to my desktop. And here's our, I created a file name that says it's a CSV, and I'm going to save it as a CSV and save. Yeah, I've already saved this one, so I'll say yes. And it will give you this little message that tells you that, first of all, it recognizes that this notebook has more than 2 sheets in it. And CSV will only save 1 sheet. So if I say OK, it's going to save that top sheet by itself. So, and then it gives me this annoying thing that tells me that I'm going to lose some of my formatting. And I say, yes, that's fine. And it saves it. Okay. And at this point, I can now go back and find that sheet and use it with my software when I'm ready. And with that, that is all we have to share with you today about how to create machine readable spreadsheets and do a better job of using spreadsheets for future applications. So I'd like to invite you to join us for future Data Bytes workshops. That's what this URL will take you to. And also, if you're interested in learning more about some of the tools we discussed, the software, then please look at the website for our carpentries workshops, and we hope to see you there.